Okay, on the quiz and on the test, there's always some things that need definitions. So they ask questions that have these definitions that are required. So on this short video, I'm going to define a few of them for you. In a system of equations with two variables, any ordered pair that makes all the equations true is a solution to the system. You can find that on your lesson viewer, page 2 of lesson 2. It says here, a set of two or more linear equations is called a system of equations. A system is special for many significant reasons. There should be as many equations as there are different variables. So if you have two variables, you got to have two equations to get a solution. If there's three equations. Okay, so if you have an x and y variable, then the system will consist of two equations. As a result, the solution of the two variables within the system must be the same for each equation in the system. Therefore, any ordered pair that makes all the equations true is a solution to the system. Remember the question now. Question 3 was, in a system of equations with two variables, any ordered pair that makes all the equations true is a solution to the system. And that last sentence on page 2 gives you the answer to that. So you know what it is. All right. Question 5 asks the question, or gives you a blank. When graphing a linear system of two equations, the point of blank of the lines marks the solution. Now, the choices are intersection, origin, slope, and no return, point of no return. I think I'd throw out point of no return. That just sounds a little dumb. All right. And here's what page 3 says of your lesson viewer. There are many ways to approach finding the solution up to a system of equations. The simplest way may be graphing method. This method relies on the concepts we already know. Once we graph both equations on the coordinate plane, the point of intersection represents the solution of the system. Okay, so that kind of answers your question there for you right off the bat. Not a problem. Okay, question number 6 says, a system of equations is inconsistent if it has at least one solution. Well, I'm going to show you a couple of types of equations here. The top one on the board here is something we call a consistent and independent solution. I don't know how well you can read what that says. Basically what I've got here is I've got two lines plotted here, and they cross. And the linear equations from which they came are 2x plus y equals 5, which we turn into a slope-intercept form, and we plot that line. So it becomes negative 2x plus 5. Well, the y-intercept for this line is plus 5. 1, 2, 3, 4, 5. There it is. And the slope is a slope of minus 2. So I go down 2 over 1, and I draw a line connecting those 2 points. Then on this side, I have x minus y equals 1. And I wind up with y equals x minus 1. My y-intercept is minus 1. My slope is a positive 1. That's 1 and 1. I draw that line, and the point of intersection is 2, 1. Only one solution. And this is consistent and independent. So that's an answer to one of your questions there. If the point of a solution to a linear system, that's not the one I wanted, because I don't have an answer to that one. You're stuck. If a system graphs equations that are the same line, it means that they have one solution. Well, let's see what that means. These two are the same line. Here's one linear equation. 9x minus 6y equals 24. 6x minus 4y equals 16. When we turn them into slope-intercept, we find out that they have the same slope, and they have the same y-intercept, so they're the same line. So each of these equations maps on top of each other. So they have an infinite number of solutions. Not just one, infinite. As many as the two lines, they're the same line. Okay? And these are called consistent because they have solutions, and dependent because they depend upon one another. Okay, now there's a third type that isn't asked for in the quiz, and that is the inconsistent equation. An inconsistent equation is one where the lines are parallel. You can tell they're parallel because they have the same slope, but they have different y-intercepts. For instance, on the second one, if this had been, say, a positive 2, that means this line would have been the exact same slope, but it would have been crossing the y at this point. And so the two lines would have been parallel. So those are some basic definitions, and they should be helpful on questions 3, 5, 6, and 10. I can't really give you a lot of help on 8 because I can't find the answer. Do your best on that one from what you learned from the lesson viewer.